Morning, everybody. We're going to look at our last bit of notes today. I think we're at 25 now. We're going to do this. We're going to do that last page. And when we get done, just hold on to these, okay? Keep them because they're always good to look back at, all right? What do you notice about this? What symbols would you put on here? Well, it looks like this is the same length as this one, right? This side looks like it's the same length as here, but I'm going to put 2 here. So these two are congruent. Top and bottom are congruent, right? Any right angles? I don't see any right angles. I bet you could extend these forever and they'll never intersect, right? So wouldn't that make them parallel? I think same deal here. Staying the same distance apart. So maybe a double arrow down here. Okay. This kind of looks like that. What was that from yesterday? The rhombus, right? The only difference is that all 4 sides were congruent. Remember, it was kind of like a square that got kind of like smushed over, right? The sides are still the same length. Well, doesn't this kind of look like a rectangle that got smushed over, right? So it lost its right angles, but the opposite sides are still congruent and they're still parallel, okay? Ooh, did I just say parallel? It's a parallelogram, okay? The opposite sides are congruent. The opposite sides are parallel. It's actually just like the rhombus. So the rhombus is kind of like a more specific version of a parallelogram. All the sides have to be equal though, okay? All right, so we're going to call this a parallelogram, and we'll say that the opposite sides are congruent and parallel, okay? 2 more here. You know this guy goes forever this way, goes forever this way, goes forever 2 different directions, and it's straight. That's a line, right? What's this one? It starts here, starts at a point, and travels forever one direction. Do you remember? It's a ray, kind of like the sun, right? The rays come out of the sun, they start here, they go one direction forever, okay? All right, I got one more page. 3 things on it, okay? All right. Oh, we got another line, right? It's just a line. Well, we've got 2 points there, so I don't think it's a line. I think it's part of a line. I think it's a line segment. And this is what we use to make most shapes, right? Starts here, stops here, goes here. You know, so it's part of a line. It doesn't go on forever. It's just kind of a section, okay? Do I have another line in here? Do I have 2 lines? Sorry about that, guys. So it goes 2 different directions forever. Just good little review, all right? Okay, the last one I have in here might be a term you've seen before. Let me zoom in for you. All right, so I got a bunch of shapes here. I got a triangle. I've got an isosceles triangle. Got a pentagon. Got a hexagon. Got a square. And there are lines that you can divide these things in half, right? So this isosceles triangle, you can divide it vertically. That's a good word. Right down the middle. This side is equal to this side, or this side is congruent to this side, right? So there's only one way to do this so it's equal on both sides. This is called a line of symmetry, or it's symmetrical, okay? So let's talk about the square. Yeah, you could do the same thing. You could divide it vertically. It's congruent on both sides, right? You could go horizontally. So now the top is equal to the bottom, okay? Or, you can't do this a lot. Couldn't you go diagonally, go from corner to corner? So another way to think about it is, can you fold it and will it match up evenly? You have to be able to fold it and have it work on both sides, okay? So we have a diagonal line of symmetry, and since that's diagonal, we have another diagonal there. So if you count them, it's actually 1, 2, 3, 4 lines of symmetry. Sorry, I get my zoom out. Wasn't this a line? Yeah, it is, but we already counted it, right? So this has 1 line of symmetry, this has 4. What does this guy have? Just 1, because I don't think you can really cut it across that way, can you? Okay, can't really go diagonal. Now, if it was a regular hexagon, if all the sides are equal, if all the angles are equal, then it would actually have 5. But this is an irregular hexagon, so it just has 1 line of symmetry, okay? All right, I have 1, 2, 3, 4, 5, 6. We have a hexagon here. It's an irregular hexagon. This side is a little longer than this side, right? So it looks like we can divide it left to right. We could fold it across. So we have a horizontal line, vertical line that folds going across. Or we could go horizontally and kind of fold it up, and it would flip over on this side, okay? So I don't think we could go corner to corner. They'd be equal on both sides, but I don't think it would fold across, okay? So we just have 2 lines of symmetry here for the hexagon, for the irregular hexagon, okay? All right, so you could say they're lines of symmetry, or it's if a shape is symmetrical. Both words work, okay? We're going to talk about this more another day, but it's just a good term to know. And if you kind of look back at some of these other shapes, a lot of them have symmetry, right? So our rhombus, congruent on both sides. Congruent on both sides, right? So you have 2 lines of symmetry here. What about the octagon? Yeah, there's actually a whole bunch. You could go from line to line. You could go from corner to corner. And since it's a regular octagon, you could actually do a whole bunch on here. We'll do that one another day, okay? What about the trapezoid? Oh, could I go across here? I don't think that's going to be equal on both sides, right? But I think I can go vertically. So I think we have 1 line of symmetry here. So we're going to look at that another day, but just something to think about, lines of symmetry, okay? All right, I'm going to throw some questions at you today about these new ones and about the old ones too. So keep the notes and keep them handy, all right? We're going to use them for the next week or two, all right? Have a great weekend. I'll catch you guys later.